Kelsey, as I mentioned, is the program manager and instructor at the International Yacht Restoration School of Technology and Trades in Newport, Rhode Island. And before we go to Kelsey, I wanted to mention that little link at the bottom of her banner right there. We've sat down and talked with both of our guests in a written extensive case studies about their success using RhinoCAM. And that link at the bottom shows you where to go if you want to read the full case study on the MecSoft.com website. So Kelsey, are you with us? How you doing?
Oh, there we go. I was muted. Hi, how are you?
Pretty good. How are you?
I'm good, thanks.
Okay, Kelsey, tell us a little bit about yourself and a little bit about the program there at the International Yacht Restoration School of Technology and Trades.
All right, my name is Kelsey Britton, and like Don said, I am the program manager and one of the instructors here at IRIS for composite technology. Our school has 4 different programs. Most of them are marina industry based, but we are branching out into other industries. And Rhino is taught to 3 out of the 4 programs. RhinoCAM is used in 2 out of those 3 programs, mostly in my program specifically. All right, so this is, at our school, we do what we call a Capstone Project, and that takes all the information that they've learned throughout the semester and turns it into one final project. What we like to do is have them choose their project because they'll be more passionate about it, which means they're apt to work harder and learn more. So Wyatt is a bicycle enthusiast, so he wanted to make a carbon fiber bicycle helmet. And that was pretty much that was the main goal, was to get a usable bicycle helmet from this project. So you can see in these pictures, what we used RhinoCAM for was to create this mold where he was able to lay up inside carbon fiber and then finally produce a helmet.
So let me ask you, what was his reaction to RhinoCAM while he was making this project?
The students are always blown away by what they can do with RhinoCAM. We start with RhinoCAD, and so they actually have to design everything on their own. Then they go into RhinoCAM, and I work with them one-on-one. And the fact that they can take, like this mold in particular was a split mold, and so just that concept alone is amazing. But being able to have RhinoCAM to be able to put in parting lines and indexing points for them, simple things like that are huge for our students.
Mm-hmm. Cool. Tell us about this project. I think this one's pretty cool.
So this is actually one of my favorite projects. This was when I had first started taking over the RhinoCAM section of our course. This is a student's, we call it a suicide wheel for his steering wheel. And actually, we pushed the student to patent his idea because it was so unique. Cool. But this was actually a challenge, getting the correct radius in on a 3-axis machine, plus getting all these minute details because it was very thin. And then again, the part was made out of carbon fiber as well. So we primarily use RhinoCAM to make all of our plugs and molds once they get to a certain point.
Yeah, we're highlighting the intersection there between the spoke and the wheel and the filleting and how the parting lines had to work out there.
Yeah, a lot of detail went into that. So, and now you can see that's one of the finished molds. That was the first one that we did. We used MDF for the first one, and then for the second one, we actually used a tooling foam that we had donated to the school. So then to give a nicer finish, and then Simon was able to use carbon fiber to, it's again another 2-part mold. So he had to make 2 parts and then glue them together.
Yeah, that's pretty thin for a carbon fiber. How did that come out? I noticed the center spoke section there.
Oh yeah. So that center spoke section, it was incredibly thin. He had to do a couple renditions to make sure that he got the finish that he was looking for, and then ultimately it came out beautiful. The suicide knob part, which you can't see, which is where that circle is, right, that's made out of aluminum. And actually in the picture where Simon is, you can see them holding that part. When he glued it all together, it came together beautifully. So between the aluminum and the carbon, it was very, very light, cosmetically beautiful. Again, we have 4 programs here, and one of them is a boat building and restoration program. It's a program where you learn how to build a boat and then you learn how to restore a boat. And a lot of our students are fortunate enough to get jobs at the Mystic Seaport. This particular group had worked on the Mayflower too. We also have another restoration program project going on campus, which is the Coronet, which is another huge historical boat, the whole entire crew as of right now are all former IRIS students. And then from here, so the greatness of IRIS is that we have the classic build of wood, and we also go into composites and digital fabrication and all those things. So I have students that work anywhere from something like the Mayflower Project to wind turbine build and repair to the American Magic, which is the New York Yacht Club's America's Cup challenging boat. So we're kind of, we're a little bit everywhere.
Well, that's cool. That's cool. Kelsey, I wanted you to stick with us for a little bit. We may have some questions for some of our attendees. Might have some questions for you at the end of the program. Do you mind keeping with us?
Not at all.
Okay, thank you. So this file right here is Simon's steering wheel composite mold. So we're just showing one half of the mold right here, and we're going to show you just a little bit of what the toolpaths were used to create this mold. So in setup 1, we have one half of the mold. Let's just show the toolpaths real quick here. We have a facing toolpath to face down the top of the mold. We have our roughing operation, which clears out the steering wheel itself and also the spoke area. And we have one of our finishing operations to clear out the actual steering wheel itself, and also another finishing operation to clean up the area where it meets the steering wheel, and also these sections of the spoke area. And then we finish up with a pencil tracing operation. So let's show some cut material simulations real quick of these. We won't run the simulations, we'll just show you what they look like, and we'll just step through them. So we got our facing, we'll just turn the toolpaths off. And then we got our roughing, and we got our first finishing operation, and then our second finishing operation, and then our pencil tracing. Okay, let's go over to our next project from Jeffrey Wyatt, or Wyatt Jeffrey, excuse me. As you can see here, here is the bicycle helmet that Wyatt used initially to create these molds here, these layup molds. And we're just showing one half of the mold, so it's basically mirrored on both sides. So there's 2 mirrored halves of this mold. So we'll go through the toolpaths and then we'll show the material simulations like we did on the other project. So we start with the facing, and then we have our 4 locator pins, and then we have our roughing operation and also a horizontal finishing operation and a parallel finishing. So let's go ahead and show the cut material simulation of those real quick. So we start with our mold half. We turn the toolpaths off so you can see them better. Got our facing, our locator pins, our roughing operation, and then our finishing. Let the screen get updated here, there. And then our parallel finishing to clean up the bottom half of that mold. So that's basically the operations for Wyatt's project. And next we're going to go back to our question and answer section here, just a second. And I was looking at the questions, and we do, Kelsey, are you still with us?
Yep, I'm still here.
Hi, thanks. Thanks for sticking with us. Sorry for the technical problems.
No worries.
Okay, we had one question here.
How I fit it into the curriculum?
What do you have them do?
So, so we have a very short amount of time with our students in my course in particular. So they're only with me for 5 months. So at the end of the first month, I start teaching them RhinoCAD. And then that's about 2 to 3 weeks of intense, in-depth learning with RhinoCAD. And then I have them, believe it or not, I have them design, I call either a sign or a nameplate or something to that effect in Rhino. And that's the first introduction to RhinoCAM that they get. So it's that way they can take a basic design, we can work through all the kinks in the design, because they design it on their own, and then I go with them to the computer and we sit down, and then they can start seeing why paying attention to detail means so much when it comes over to the RhinoCAM section. And that's their first project. Then after that, it goes into their Capstone project. And that's when they start using it to either make plugs or molds for their final project. But it all happens very, very fast.
What are you finding as far as feedback from the students about what's easiest for them to grasp, and what seems to be the most difficult thing for them to grasp?
Once they start working through all the troubleshooting on the design end, they love RhinoCAM. They think it's actually pretty user friendly. And speaking of those resources, I use those resources for my students all the time, to have them look through. They're so incredibly helpful. But I find that just having them do it a little bit, they just seem to love it. So RhinoCAM has become so much more user friendly over the last few years as I've been using it more and more. I think that the user-friendly aspects and all the helpful hints and everything has made it a lot easier for students. It's easier for me to teach them RhinoCAM than it is for me to teach them RhinoCAD, believe it or not.
Oh, that's interesting. Also, we had another question here about the Mayflower Project. One attendee was wondering if you were able to sail on that, or does any of your students get to sail on it, or did they? I guess it's already sailed.
It's already sailed. So I think some of the boat building students and faculty were able to get out, at least on it. I don't know if they got to sail on it or not. But unfortunately, the rest of us have not, no. But we did actually, so there's a sailboat over here, our yacht rather, called Aurora. And we actually, our first day of school was yesterday, so a lot of our students went out on that. So we get them out when we can. Okay,
that's great. If there's any other questions, go ahead and ask them now. At this time, I usually, tell everyone how much we really appreciate our educators and what they're doing with RhinoCAM and with the students. And I actually wanted to tell you a quote from Kelsey. I told her ahead of time I was going to do this, so I'm going to go ahead and do it since we have the time. I haven't read a better quote from an educator in my years here at MecSoft, and I couldn't have written it any better. And I'm just going to read it to you. The marine industry and shipbuilding specifically is more a lifestyle than a job. I love what I do, teaching others how to find that passion and help them move forward in life, and hopefully continue to work in the machine industry. That's a wonderful quote, Kelsey. I appreciate you being here, and I appreciate everything that you're doing to help your students get ahead in life and to get them ready for the next stages in their professional careers. Thank you. Okay, everyone, we're going to wrap it up for now, and we're going to record it and get the recording ready for you to download, and so you can watch the whole recording. If you may have missed some at the beginning, you'll be able to watch it in full. Thank you, everybody. Take care.